Welcome to the Deep Dive, where we take a stack of information and distill it into those vital nuggets of knowledge, giving you a shortcut to being truly well-informed. Today, we're embarking on a fascinating journey into something that is so fundamental to our daily lives, so integrated into the fabric of global connection, that we rarely stop to consider its incredible evolution: the telephone. Just take a moment to consider the sheer marvel of it, a device that lets you instantly connect across vast distances, hearing the voice of someone thousands of miles away as if they're standing right beside you. From whispered secrets to urgent news, it has transformed human interaction. For this deep dive, we've gathered a rich array of source material, a comprehensive look at the telephone's remarkable journey, tracing its path from its earliest, perhaps surprising, conceptualizations all the way to the powerful smartphones that now reside in our pockets. Our mission today is to truly unpack the captivating history of this device. We'll navigate the intriguing controversies surrounding its invention, explore the monumental leaps in technology that defined each successive era, and ultimately gain a profound appreciation for how a deceptively simple concept, the distant voice, has reshaped global communication as we know it. You're about to uncover some truly eye-opening insights, I assure you.
And what's truly captivating about this topic is just how much the very definition of telephone has expanded and shifted over time. We'll peel back the layers, starting at the absolute beginning, even before electricity entered the picture, to fully grasp the foundational human desires and inventive ideas that ultimately led to this indispensable technology. It's a story woven from threads of human ingenuity, relentless incremental improvements, and frankly, some exceptionally clever problem-solving under significant constraints. So what does this extraordinary journey reveal about our intrinsic need for connection and the relentless pursuit of making the impossible possible? Let's delve in.
Okay, let's unpack this. It's kind of wild to think that the concept of a telephone was literally just about amplifying sound to reach further, long before wires or electricity were even in the picture. It really sets the stage for how revolutionary the electrical leap was.
Exactly. And the word itself, telephone, actually existed before the electric device we all think of.
Really?
Yeah, it comes from ancient Greek. Tyle, which means far, and phuna, meaning voice. So literally, distant voice.
Distant voice. That makes perfect sense.
It perfectly captures that fundamental human need,
Yeah.
the desire to communicate across space. It tells us the problem, the idea, was there long before the tech. Take Gottfried Huth, for example, way back in 1796. No wires, no electricity. He proposed a telephone as an alternative to the optical telegraph.
Okay, so how did his work?
His idea was, well, ingenious for the time, but pretty basic. Operators in signaling towers would shout to each other through what he called speaking tubes. Think giant megaphones.
Wow, just massive megaphones to shout across the landscape.
Pretty much. The goal was simply to extend the natural range of the human voice, make it travel further.
That paints a vivid picture. And he wasn't the only one thinking along those lines.
Not at all. We also have Captain John Taylor in 1844. He invented his own device, also called a telephone.
Okay.
Taylor's was designed for something really practical, communicating with sailing vessels in fog. It used 4 powerful air horns.
Air horns. So again, purely acoustic, just moving air.
Exactly. These examples make it super clear the driving force wasn't electricity initially. It was this deep-seated human need to communicate over distance, using whatever tools they had, basically. Acoustic tool.
It really underscores that fundamental need for connection, doesn't it? Trying to overcome physical barriers with just sound.
It does. These early acoustic telephones laid the conceptual groundwork. They framed the challenge that the electric telephone would eventually solve. They were like the first draft of the dream.
So we're seeing these early innovators almost feeling their way towards the future of communication, even without the electrical means. It really highlights that big breakthroughs are rarely just one person, one perfect invention, right? It's a process.
You've hit on a critical point. The journey from speaking tubes to actual electrical voice transmission was complex. Several brilliant minds contributed crucial pieces. The next huge step involved bringing electricity into the picture. And that's where Johann Philipp Reis comes in, around 1860.
Okay, Reese.
He's credited with building what many consider the first device that could transmit voice using electronic signals. And importantly, he coined the term telephone for his invention.
So he applied the old word to this new electrical thing.
Right. It was a massive leap from just acoustics.
And there's that famous, slightly odd phrase associated with him.
Ah, yes. He famously transmitted, Das Pferd frisst keinen Gurkensalat.
Which means?
The horse does not eat cucumber salad.
Chuckles. Okay, maybe not world-changing content, but the principle was huge.
Exactly. Converting sound to electrical impulses, sending them down a wire, turning them back into sound, that was the core concept. And it's worth noting, even before Reese built his device, Charles Bourseul had published an article back in 1854, sort of theoretically describing a make-and-break type transmitter. Reese essentially brought that idea to life.
Make and break. What does that mean, technically, and why was it a limitation?
Well, think of it like tapping a telegraph key really fast. Reese's method used circuits that rapidly opened and closed, made and broke contact. This produced intermittent electrical pulses, not a continuous flow.
So the sound wasn't smooth.
Right. It resulted in a series of clicks and buzzes. You could maybe recognize the rhythm of speech, but it was garbled, not clear conversation. You couldn't really capture the smooth waves of a human voice.
Ah, okay. So it worked, sort of, but wasn't good enough for proper talking.
Precisely. But that limitation was actually crucial. It showed the next problem that needed solving: how to transmit a continuous, fluctuating electrical signal that could accurately mimic speech.
Yeah.
That set the stage for the next big breakthrough.
And this is where the story gets really juicy and pretty contentious, right? The actual invention credit.
Oh, absolutely. It's a classic story, like with the light bulb or radio. Multiple people were working on similar problems at the same time. Technology was advancing fast.
So who are the main players in this telephone invention race?
Well, the key figures tangled up in all the claims and patents were Antonio Meucci, Elisha Gray, and of course Alexander Graham Bell. There were others, but these three are central to the controversy.
Okay, let's dig into that. Meucci, for instance, he was working on this really early, wasn't he?
Incredibly early. He developed a voice communication device way back in 1849, and he filed something called a patent caveat in 1871.
A caveat? What's that exactly? Like a placeholder?
Sort of, yeah. It was an unverified notice saying, "I intend to file a patent for this later." It wasn't the full patent itself. His caveat was titled Sound Telegraph and clearly described transmitting voice by wire.
But he didn't follow through.
Unfortunately for him, no. He didn't renew the caveat after 1874, apparently because he couldn't afford the fee. That failure to renew became a huge factor later on.
Wow, so close. Okay, so then Bell comes along. What was his crucial insight that set him apart, legally at least?
Bell's genius, the thing that underpinned his master patent, was grasping the need for a continuously fluctuating current, what he called an undulating current.
Undulating current. Different from Reese's make and break.
Totally different.
Yeah.
Bell realized that to capture the richness and clarity of the human voice, the electrical signal had to smoothly rise and fall, perfectly mirroring the vibrations of the sound waves, not just on-off pulses.
Like a continuous electrical wave mimicking the sound wave.
Exactly. We now understand it as a form of amplitude modulation. That was the breakthrough. And this became the core of his patent application, Improvements in Telegraphy, filed on February 14, 1876.
February 14th, 1876. And this is where it gets almost unbelievable, right? The timing with Elisha Gray.
It's uncanny.
Uh-huh.
On the exact same day, February 14th, Elisha Gray filed his own patent caveat for a liquid transmitter design.
The same day. You couldn't make it up.
Right. The patent office even noticed the overlap and notified Gray about an interference just 5 days later. But Gray, for reasons debated by historians, decided not to pursue his caveat. He essentially stepped aside.
Which cleared the path for Bell.
It did. This whole episode really highlights how legal strategy and timing, along with the specific technical method, were just as vital as the initial idea. Bell's U.S. patent 174,465 was granted on March 7, 1876.
And then came the famous first words.
Just 3 days later, March 10, 1876. The first successful transmission of clear, intelligible speech. Bell spoke into the device.
Mr. Watson, come here. I want to see you.
The iconic line, and crucially, his assistant, Thomas Watson, heard it distinctly. Real words, not just noise. That was the moment.
Must have been absolutely electrifying, pun intended.
Chuckles, no doubt. And we should also mention Tivadar Puskás, a Hungarian engineer. Shortly after Bell's patent in 1876, he proposed the telephone switchboard or exchange.
Ah, the exchange. That's the key to connecting lots of people, not just two.
Exactly. That invention was pivotal for creating networks. It moved the telephone from a point-to-point novelty to a potential system.
Okay, so Bell gets the patent. Watson hears the words. What did these very early phones actually look and feel like? I imagine they weren't exactly user-friendly.
Definitely not sleek. Early telephones were technically quite diverse. Different inventors tried different approaches. Some use a water microphone, where sound vibrated a diaphragm that changed the resistance of water.
Water. Wow.
Others were dynamic, using vibrating coils in magnetic field, kind of like a modern speaker working in reverse. Ingenious stuff, but often crude by our standards.
Just getting sound to travel electrically at all must have felt like magic.
It really was cutting edge.
Yeah.
And then came a really important improvement. The Edison-Berliner carbon transmitter.
Okay, Edison's involved too.
Yes. This design used carbon granules that changed resistance when compressed by sound waves. It was much, much louder and clearer than earlier types.
Louder is good.
Absolutely critical for practicality. Interestingly, it needed an induction coil, a transformer to work efficiently with the phone line, but the improvement in volume was massive. Edison's patents on this were so key, they helped Bell maintain its monopoly for years.
So these weren't plug and play. What was the power situation?
Initially, they were locally powered. You'd have a big battery right there at the phone's location.
In your house.
Yep. And a technician would have to come around periodically just to check and maintain the battery.
Wow. High maintenance.
Very.
Yeah.
Later on, thankfully, they figured out how to power the phones from the central exchange over the same wire's common battery systems. That was a huge step for convenience.
And the physical act of using the earliest ones, I heard it was awkward.
Oh, very. Some of the earliest dynamic phones had only one opening. You had to listen, then quickly move your mouth to the same hole and shout into it, then switch back to listen.
Like a walkie-talkie, but worse.
Kind of, yeah. Very awkward. To get around that, sometimes they'd install phones in pairs, one to talk into, one to listen with. More convenient, but obviously more expensive.
And how did you signal someone to shout louder?
Chuckles? Initially, yes. Or whistle loudly into the mouthpiece. That was the original ring.
You had to whistle to get someone's attention. Seriously.
Seriously. Yeah. But bells were added pretty quickly. First, they needed a whole separate wire just for the bell circuit.
Inefficient.
Right. The clever bit came later. Figuring out how to send the AC ringing signal over the same wire as the DC voice signal, using a capacitor to separate them. That was neat engineering.
Okay, so we have the basic device. How do we get from these point-to-point connections or awkward single-hole phones to an actual network?
Well, that initial phase, as we touched on, was very basic. Phones were often leased in pairs, connecting specific points, like a home and a shop. You'd hire someone to literally string a wire between the two places.
Totally impractical for widespread use, right? You'd need millions of wires.
Exactly. If you want to talk to 10 people, you'd need 10 separate lines and 10 phones.
Yeah.
So the concept of the central switchboard, already used for telegraphs, was adopted very quickly.
The operator model.
Right. Companies like Western Union and Bell saw the potential immediately. Connect everyone to a central hub, an exchange, and have operators physically connect the lines for each call. That was the birth of the network.
So operators with patch cords literally connecting callers.
Yep. It was still complex. Early attempts at automation, like the Strauger switch, were mechanical marvels, but incredibly intricate. Some needed 7 wires per phone line.
7 wires. Wow. Automation was tough back then.
Very. But this shift to exchanges was fundamental. It allowed the system to scale.
And this network evolution must have influenced the design of the phones themselves, making them more user-friendly.
Absolutely. Around the 1890s, a new style emerged, often in 3 parts. You have the transmitter on a stand, the iconic candlestick phone.
Ah, the candlestick. Everyone knows that look.
Exactly. Then the receiver hung separately on a hook. And that hook wasn't just a holder, it was the switch hook.
Right, you mentioned that lifting the receiver connected the call.
Yes, and hanging up disconnected it.
Ah.
Super practical. It stopped people accidentally leaving the line open.
Smart. And what about the ringing? Was that built in yet?
Not always. If you were on an older magneto exchange where you had to crank a handle to generate power to signal the operator, you often had a separate wooden box on the wall.
The bell box.
Right, or ringer box.
Huh?
It housed the bell, the induction coil, the battery if needed, and that hand crank magneto. For newer common battery systems powered by the exchange, that box could be hidden away, making the phone itself look sleeker.
So design was definitely improving, becoming less like industrial equipment and more like something for a home.
Definitely moved towards user-friendliness.
Uh-huh.
And besides the candlestick, another design gained popularity, the cradle phone.
Okay, what was that?
This had a combined receiver and transmitter in one piece, the handset that you held to your ear and mouth. It rested in a cradle on the base unit.
Ah, like the phones many of us grew up with, but the earlier versions.
Exactly. They were often bulkier than candlesticks, but more convenient because you held everything in one hand. More ergonomic.
Okay, so networks are growing, designs are improving. But what about the call quality? Those early single-wire lines you mentioned sounded prone to problems.
They absolutely were. Using the Earth as the return path, that single-wire setup led to lots of crosstalk. You could sometimes hear other conversations faintly in the background.
Not very private.
Not at all. And hum from nearby AC power lines was a constant annoyance, just a background buzz.
So how did they fix that?
The big solution was adopting twisted pair wiring. Twisting the two wires of a circuit together helps cancel out electromagnetic interference. It's a simple but incredibly effective technique we still use today.
Okay, twisted pairs. Good for noise.
And for really long distances, they developed four-wire circuits, basically separate pairs for transmitting and receiving. This helps reduce echo and signal loss on those long hauls.
Still, making a long-distance call wasn't easy back then, was it?
Oh, not at all. Early 20th century, you couldn't just dial someone in another city. You had to literally make an appointment with a long-distance operator, maybe days in advance.
Book a time slot for your call.
Pretty much. The operator would then set up the connection at the appointed time. It was a planned event, quite formal. Shows you how manual the network still was.
A long way from just picking up the phone. So the path to that modern convenience involved more standardization and automation.
Definitely. The Bell Model 202 desk set, emerging in the early 20th century, became arguably the most popular and long-lasting design.
The classic black plastic one.
That's the one. It combined the carbon transmitter and receiver into that single molded plastic handset. Super robust, super recognizable. Its internal wiring was also refined for better performance.
And then they managed to get rid of the separate bell box entirely.
Yes. By the 1930s, designs emerged that integrated the bell and induction coil right into the base of the desk set, everything in one unit. Much neater.
And the rotary dial became standard around then, too. Finally, customer dialing.
Exactly. The rotary dial became commonplace, allowing people to dial local numbers directly in many areas. Huge step. But those old magneto systems with a hand crank, they stuck around in some places for a surprisingly long time.
Right. You mentioned that Bryant Pond, Maine story. That's incredible.
Isn't it? Still using hand crank phones until October 1983. It really shows how uneven technological rollout can be, especially in rural areas. Reliability sometimes trumped modernity.
It makes sense. If it works, why fix it, especially if upgrading is expensive?
Precisely. After World War II, though, network expansion exploded. This led to more efficient designs like the Model 500 in the U.S., built for reliability on the growing network.
And then the next big user interface change.
Touch tone. Introduced by AT&T in 1963, push-button dialing, faster, more accurate, and crucially, those tones could be used to interact with automated systems. That opened up a whole new world beyond just making calls.
Right, like phone banking or navigating menus, the start of interacting with the network, not just through it.
Exactly. A truly transformative moment.
Okay, so that covers the main evolution of the standard telephone network. But what about specialized phones? You mentioned sound-powered ones earlier, which sound fascinating.
They really are. A sound-powered telephone is kind of amazing in its simplicity. It transmits voice using only the energy from the speaker's voice. No batteries, no external power for the actual talking part.
How does that even work?
It uses a moving coil microphone. Sound waves vibrate a coil in a magnetic field, generating a tiny electrical current. That current travels down the wire, and at the other end, an identical mechanism works in reverse, turning the electricity back into sound. Pure energy conversion.
So literally powered by your voice. But how do you ring someone? You still need power for a bell, right?
Good point. Usually, you alert the other person using a hand crank magneto generator, just like those old exchange systems, that powers a buzzer or bell. So cranking for attention, voice power for talking.
Okay, that makes sense. A hybrid approach.
Some systems can use external power for louder ringers or amplifiers, but they're designed to fail safe back to pure sound power if the electricity goes out. Reliability is key. They use twisted pair wires, just like regular phones, to keep the signal clean.
And you said they can work over pretty long distances.
They're remarkably long. Some systems can communicate effectively up to 30 miles, or about 48 kilometers, apart with the right wiring.
30 miles on voice power alone. That's incredible. Why are these still used today? They sound almost antique.
Because of that incredible reliability and safety, they work when the power grid is down, period. And because they operate on such low electrical energy generated by voice, there's virtually no risk of sparks.
Ah, so crucial in hazardous environments.
Exactly. Think mining, chemical plants, oil rigs, arsenals, places where a stray spark could be catastrophic. Also, airports, railways, utilities, ski slopes, bridges, military ships. Anywhere, communication absolutely must work, even if everything else fails.
On naval ships, even during battle damage.
Precisely. They often run redundant sound-powered circuits through different parts of the ship, so communication stays up even if one area is hit. It's simple, robust, life-saving tech.
It really shows that sometimes the simplest solution is the best, especially when reliability is paramount. Okay, let's shift gears now to the digital revolution. The transistor changed everything, didn't it?
Fundamentally, the invention of the transistor in 1947 was the spark. Over several decades, it completely reshaped telephone systems and networks. Miniaturization, efficiency, reliability, it enabled it all.
Ushering in digital telephony, converting voice into ones and zeros.
Right. This involves several key things. Stored program control, basically. Computers running the exchanges. MOS integrated circuits for electronic switching, replacing bulky mechanical parts, and new transmission tech like pulse code modulation, PCM.
PCM. That's the standard way to digitize audio, right?
It is. Sampling the analog wave thousands of times per second and converting each sample into a digital value. This allowed for much higher capacity, way better quality because digital signals resist noise and lower costs. You could pack many more digital calls onto the same lines compared to analog.
And this led to things like ISDN.
Yes, Integrated Services Digital Network, launched in the 80s, it aimed to provide digital connections to homes and businesses carrying voice, data, video, all over the same line. A vision of digital convergence.
Which really set the stage for the next massive disruption, VoIP, Voice over Internet Protocol.
Absolutely. Once digital data communication, especially the internet, took off, it became possible to chop up digitized voice into data packets and send them across computer networks in real time. That's VoIP.
And it completely turned the telecom industry upside down.
It was, and is, hugely disruptive. VoIP rapidly started replacing traditional phone network infrastructure. It's more flexible, generally cheaper, and integrates easily with other internet services.
The growth must have been astronomical.
Incredible. By early 2005, maybe 10% of phone users in places like Japan and South Korea were already using digital phone services, mostly VoIP. Fast forward to 2021, the global VoIP market was worth over $85 billion, projected to pass $100 billion by 2026. It just took over.
So how does it work for the end user? What do you need?
You need a good internet connection, obviously. Then the equipment can vary. You might use an ATA analog telephone adapter. That's a little box that lets you plug your old traditional phone into your internet router.
Okay, bridging the gap.
Or you could have a dedicated IP phone, which looks like a regular office phone, but plugs directly into the network with an Ethernet cable. Or, increasingly common, just use a soft phone app on your computer or smartphone with a headset.
And it's gone mobile now too, right? It's not just for desk phones anymore.
Definitely. Technologies like VoLTE Voice over LTE and now Vo5G Voice over 5G integrate VoIP directly into mobile networks. Your voice call just becomes another stream of data packets over the mobile data connection. High quality, seamless.
But there are downsides, right? Power being a big one.
That's a key difference. Old analog phones got power from the phone line itself. They often work during blackouts. VoIP phones and adapters need local power. If your power goes out, your internet router goes down, and so does your phone service.
And emergency calls. 911 or 112.
That's another challenge. Traditional landlines have a fixed location. With VoIP, especially if you move your adapter or use a soft phone, the system needs special mechanisms like E911 in the US to accurately report your location to emergency services. It's gotten much better, but it's something to be aware of.
Okay, good points. Now, before true mobile phones, we had cordless phones. Freedom within the house.
Right, a stepping stone to full mobility. A cordless system has a base station plugged into the phone line, or VoIP adapter, and one or more portable handsets that communicate with the base via radio signals.
Limited range, though.
Yeah, usually just within the same building or maybe out into the yard. But it was huge, not being tied to the wall by a cord.
And those base stations often had extra features.
Lots. Speakerphone, caller ID, maybe a built-in answering machine. The handsets have rechargeable batteries that charge when you put them back in the base. But again, the whole system needs electricity to work. No power, no cordless phone.
A precursor to true mobile freedom. Which brings us to mobile phones, or cell phones. Game changer.
The ultimate untethering. A mobile phone connects wirelessly via radio to a cellular network. That network is made up of all those cell towers or base stations you see around.
And those towers connect back to the main phone network.
Exactly. The first analog cellular networks popped up around 1979. Then digital networks, like GSM, started in the early 90s. Each generation, 2G, 3G, 4G, 5G, brought better voice and, crucially, much faster data speeds and more features.
And inside nearly every mobile phone is that tiny, essential chip, the SIM card.
The subscriber identity module, small but mighty. It stores your unique ISI number and authentication keys. It's how the network identifies you and authorizes your service. Your phone's passport, basically.
And mobile phones quickly became more than just phones, didn't they?
Oh, absolutely. Starting in the 90s, features piled on. SMS text messaging was revolutionary. Then MMS for pictures and videos, calendars, alarms, basic organizers. Then cameras became standard, music players, games. And finally, proper internet access, leading to smartphones.
The operating systems changed too. I remember Symbian, BlackBerry.
Right, Palm OS, Windows Mobile. It was a diverse field. But since then, Google's Android and Apple's iOS have become overwhelmingly dominant, a real duopoly.
And the makers changed too. Less Nokia, Motorola, more Apple, Samsung.
Exactly. Consumer electronics giants jumped in big time. Which leads to the question you raised. How did these things become such an essential part of us?
Which is really the story of the smartphone.
Pretty much. As of now, most mobile phones are smartphones. They merge a phone and a powerful personal computer into one device.
Operated mainly by touch screens and graphical interfaces.
Primarily, yes. Though voice interfaces like Siri or Google Assistant are becoming increasingly important for control and interaction. Text input is usually via on-screen keyboards, though a few physical keyboard models still exist.
And their connectivity is just immense.
Totally. Cellular data, Wi-Fi, Bluetooth for accessories, wired connections like USB-C or Lightning, and the functionality is defined by apps, millions of them for everything imaginable. Video calling became easy. Web browsing, email, maps, navigation.
It's like a pocket-sized command center for your life.
It really is. Packed with sensors too, cameras, GPS, accelerometers, compasses.
Yeah.
And we communicate using everything from SMS and email to iMessage, WhatsApp, and countless social media platforms. It's way beyond just being a telephone.
The adoption rate you mentioned earlier was staggering. That jumped from 10% to 46% global mobile use between 2002 and 2005.
It's hard to even comprehend that speed. It shows the pent-up demand and the sheer utility people found in mobile communication.
And by 2009, nearly 6 billion total phone subscribers worldwide, with mobile far outweighing fixed lines.
4.6 billion mobile subscribers by then. It had clearly become the dominant way people connected globally. A massive shift.
Oh, one last category. Satellite phones. For when you're truly off the grid.
The ultimate fallback. A sat phone bypasses cell towers entirely. It connects via radio link directly to satellites orbiting Earth.
So it works anywhere with a clear view of the sky.
Pretty much. Depending on the satellite network, some are global, some regional. You can make calls from the middle of the ocean, the desert, the polar regions, anywhere terrestrial networks don't reach.
And you mentioned their reliability is a key factor.
Huge factor.
Yeah.
They often keep working through natural disasters or conflicts that knock out ground infrastructure. That makes them vital for emergency response, remote expeditions, maritime use, humanitarian aid, mining in remote areas.
They offer similar functions to regular mobiles, calling, texting.
Yes, voice text and often low bandwidth internet access.
Yeah.
Enough for email or basic data. Their main advantages and features, it's that sheer availability in places where nothing else works. A true lifeline. So if we try and wrap our heads around this whole journey, connecting it all, it's just incredible that simple ancient human desire for a distant voice has driven this relentless wave of innovation. From shouting tubes and air horns through all the electrical discoveries, the network building, the digital revolution, right up to these global satellite-linked computers in our pockets. It's quite a story.
It really is. And we've seen how messy invention can be collaborative, contested, evolving constantly. The telephone wasn't just invented, it's been reinvented over and over. From that basic device to this multi-tool powerhouse that's so central to everything we do. Hopefully, you listening now have a much deeper appreciation for the journey and the layers of tech involved. This deep dive wasn't just about a gadget, was it? It was about the continuous reinvention of connection itself. How we bridge distance. So thinking about all this, what does it mean for your understanding of the world and that device you probably have within reach right now?
And that leads to a final, maybe provocative question for you to think about. We've seen voice integrated with electricity, then digital networks, then the internet, now mobile computing. As our distant voices get increasingly tangled up with AI, with virtual reality, maybe even direct brain interfaces down the line, what's the next fundamental shift going to be? What will the telephone of the future really look, feel, or even sound like?